So, could somebody read out 2A, please?
What are the answers to the following? 14.256 plus 2.6.
You're adding these values up, so it's 16.856. But this is not your final answer. Look at the columns. We're adding.
Yeah, it was 2.3.
16.55.
It's plus 2.3.
2.3.
2.3. It's not going to change our answer significantly. 2.3.
Yeah, isn't it with the round digits?
No. No. We're adding and subtracting rules here. Column. 10th. This is not, right? This number is more accurate than this number. You cannot have a final answer more accurate than your least accurate number. So when you round this answer off, it's got to be to the 10th column. You've got to look at the position of your last digit in each one of your numbers when you're adding and subtracting. So we have to round to this value. So your final answer, 16.6. You've got to look at the column. But I think you did put 17.0, didn't you?
Yeah, I did.
Yeah, so I remember looking at that going, okay, so she's got the rule, but she didn't do the answer. Okay. The next question, Ankit.
The B is 13.5 times 100.
How many significant digits in 13.5? How many in 100? So your final answer can only have one significant digit. Well, what is the answer when you multiply 13.5 times 100? 1,350. You can only have one digit in your final answer. So it's going to be 1,000 or 1 times 10 to the 3. So this is all about adding, subtracting. This one's multiplying and dividing.
So if we put like 1 point something to get the mark off, 1.17, 1.17,
Wait, why is it 3? Because
There's only one significant digit, so there's only one.
so
Can't have 0.4.
so like it would have to be 3, 2, 6, 0.
We know it's a molecule because the question tells us. And it gives you the mass. 2.653 times 10 to the negative 22 grams. What is it asking for? What units? The molar mass. So it wants grams per mole. Do you want formulas or do you want dimensional analysis? If you want, oh, somebody over here said dimension, I'll do both. Okay. Formulas first. We don't have moles, so you have to calculate moles, but we have the number of particles. So N, big N over NA, that's 1. Now you have moles. Now you take your mass, divide by moles. If you're going to do this using dimensional analysis, what unit has to be on top? What unit do we need to be on top if we're finding molar mass? Shall I say it again? What unit has to be on top? No, grams. Grams. What has to be on the bottom? Moles. So, start with, which one of these has grams in it? Which one has grams in it? The one at the bottom. So that's where you're starting. Which one of these terms up here has moles in it? Come on. The second one, right? Is moles where we want it to be? Is it on the bottom? So we're going to keep it like it is. But we've got to get rid of what? Molecules. That's all you got to do. So one molecule cancels. Multiply the numbers on top, divide by the numbers on the bottom. Some of you got the right answer, but you did not include this at all. So you lost part marks just for not showing all of your work. So it's 55.85 atomic mass units per atom, or 55.85 grams per mole. So if you want atomic mass units, you just multiply these two numbers, right? But you don't use that number again. N is 25. Na is Avogadro's number. So now you can find moles. Once you have moles, you've got molar mass, you can figure out grams. Do you use formulas or do you use dimensional analysis? So, that's all you have to do. Some of you, and it wasn't one person, it was probably a handful of people, had extremely large mass in terms of grams. Which means 25 atoms that you can't see are actually end up being heavier than the planet Earth. This is what I talked about. You got to check, make sure your answers make sense. If you've got 25 atoms or 20 atoms or 100 atoms of anything, it's a really small mass. So your times 10 should be a negative value because it's an extremely small value. So always take that time at the end, and I gave you extra time if you needed it. Double check your answers. Is it a big number or a small number? Geometry then. This is the relationships between substances in a balanced chemical equation. So we're going to set them up as ratios, these relationships. Okay. First thing you need to do when you get a question is ask yourself, do I have a balanced chemical equation?
Nope. No.
So balance it. Okay.
So 2 in front of H2, and then 2 in front of H4.
All right. Stoichiometrically, 2 molecules of hydrogen gas have to react with 1 molecule of oxygen gas to produce 2 molecules of water. I got those values from your balanced chemical equation. 2, 1, and 2. So I would like you to write the ratio of molecules of hydrogen to molecules of oxygen. Brianna, what did you write down?
Do you want it reduced or just normal?
Hydrogen to oxygen, just normal.
Hydrogen to 2 oxygen.
What did
4
you,
hydrogen to 2 oxygen.
where'd you get the 4 from?
2 times, like.
Are you multiplying these?
Oh, do you not? Okay.
No. I want, based on what's in the equation, in terms of molecules. I didn't stress that. Hydrogen to oxygen. 2 to 1. 2 hydrogens to 1 oxygen. Is that the only way to write this? Nathu, what do you think?
Couldn't you do like 1 oxygen to 2 hydrogens?
Absolutely. Absolutely. What would be the relationship between oxygen and water? O2 and water. Nick?
1 for every 1 H2 or 2 H2s.
Yeah. So where am I pulling those numbers from? The chemical equation. You're going to have to do this. You're going to have to do this, okay? Here's your next chemical equation. So let's set up a balanced chemical equation, and then I want you to write the relationship between hydrogen and nitrogen. So I want the relationship between hydrogen and nitrogen. Emily, do you have it balanced?
Oh, I was doing the ratio.
Oh, it's got to be balanced first. Ryan, what'd you put for the balanced? I'm still working on it. Sorry.
For the balance?
Yeah.
3 in front of the H2,
Yeah?
and then 2 in front of the NH3.
All right. So what's the relationship then between nitrogen and hydrogen using words? Using words. Sasha.
For every 1 nitrogen, 3 nitrogen.
Every 1 what nitrogen? Fill in the
1 molecule.
1 molecule requires 3 molecules of hydrogen, or we can say 1 mole of nitrogen requires 3 moles of hydrogen. Okay, so what happens if I have 2 moles of hydrogen? How many moles of ammonia could I produce? I've got 2 moles of hydrogen. I want to figure out how many moles of ammonia I could produce. So what you have to do in this question is set up the mole ratio of ammonia to hydrogen. Do we want H2 in our final answer? No. So when you set up your ratio, you want hydrogen to be on the bottom. So I want ammonia. I don't want hydrogen. And the mole ratio is 2 of these for every 3 of these. H2 will now cancel. My units are now going to be moles of NH3. So what's 2 times 2 divided by 3? Okay, so 1.3 moles of ammonia can be produced. How much nitrogen will I need? How much nitrogen will I need? Now we're looking for nitrogen, so it's going to go on top. We don't want hydrogen. It's going to go on the bottom. And then you put in the values for your mole ratio based on your balanced chemical equation. So it's a 1:3 ratio. So this part in the middle that we've been doing, this part here, these are called mole ratios. And we use these in stoichiometry to go between reactants and products, or products and products. So these are mole ratios, and you're going to use them from now on. But that is the only time we're going to use those coefficients, okay? So how much nitrogen will we need? Two divided by 3? 2/3? 0 point? So if I want to do a reaction between these two, I will need 2/3 of a mole of nitrogen to 2 moles of hydrogen, and I can produce 1.3 moles of ammonia if I use that much. So this is the kind of thing you have to be thinking about when you're trying to predict how much substance you want to make. If you're working in a chemical factory and you're a chemical technician, you're going to need to know how much stuff to put in to maximize your output. You don't want to just make it random because then you're wasting money because you're putting in chemicals you don't need. So there's lots of factors that you have to consider, just like baking. You bake a pie, you bake a cake, you don't just randomly crack a whole bunch of eggs, throw them in, mix them up, and hope that you got something good at the end. Sometimes just throwing in the wrong ingredient or the wrong amount will really mess up your food. And this always comes back to food, okay? Do you want to do another question? All right, how about aluminum plus, how do you write bromine? Br2, because it's a diatomic element. Makes aluminum bromide. If we make 5 moles of it, how much bromine will we need? See if you can figure it out. How much bromine will we need to produce 5 moles of aluminum bromide? So now what do we do? Where do you want to start? Start with what you know. Ankit?
I felt like the ratio between how many ales per beer.
Okay.
1 to 3. 1 ale for every 3.
I don't see any 1 up there. We're trying to figure out how many molecules of bromine. Sorry, how many moles of bromine that we need. What's the ratio?
2 to 3, but like 2 AL and then 3 bromine 2.
Yeah, so which one do you want? You can even start with your mole ratio if you want, because it's got the units that you're looking for. So we have 5 moles of aluminum bromide. Emily said we've got 2 aluminum bromides for every 3 bromines. Aluminum bromide will cancel. So now you're left with moles of bromine. So 5 times 3, 15, divided by 2, 7.5. Yeah.
So for the 2 to 3 ratio, where did the 2 come from? Was it like the 2 AL? Wouldn't that make 6 BR?
But we're not talking atoms. We're talking actual substance, right? Which is Br2.
BR2 is just 1.
Okay? Did we need to know how many for aluminum? Did we need to use that at all? No. The only time you're going to use that is if you have to figure out how much aluminum you need as well. So why don't you figure that out right now? How many moles of aluminum do you need?